Hi all. So today we will be taking a look at the new exciting feature which is introduced in Angular 16, that is Angular Signals. So there has been a lot of hype around this feature. So today we will be taking a look at only the very basics of this Angular Signals. What is an Angular Signal? It's basically a mechanism which is used for tracking the state of our application and at a very granular level, and it helps us to run the change detection at a very minimum level, that is at a view level. By making use of signals, we will be able to reduce the scope of the change detection. So let's get started. So here I have created an Angular 16 application, and within this I have created an app component and within it a child component. So as of now the child component will always be shown, and here let's create a signal. So a signal is a kind of a wrapper function which wraps a value underneath. So the value can be a primitive or an object. So let's start with a simple signal which wraps a number. So I am going to create a signal, name it as count. So this is a property of the class, and for creating the signal you can call the signal function, and as an argument you can pass the initial value. So initially I am setting the value as 0. So now a signal is created. The signals can be of two types, that is either it is writable or it can be read-only. So when we make use of the signal function, we create a writable signal. So this is the type writable signal, and there you can define it as a number since we are setting the value as 0. Now let's do one thing. Let's bind this signal to our HTML template. So here within the template, let's give the count. So normally when we make use of a property, we just give the name of the property. But in the case of a signal, if you give it like this, you can see that when the application is rendered, it is basically a function. Signal is a wrapper function which mainly acts as a getter. So in order to access the value within this wrapper, you need to call the function. So now let's call this function or call the signal, and now you can see that the actual value which is wrapped inside is displayed. So this is the way in which we will be able to access the value within a signal. So I mentioned that the count signal, which is actually a writable signal. So now let's see how we can update the value within this signal. There are two methods in which you can update. One is you can set the value directly. So here I have created a method called set value, and we can call the set method within the signal and pass the new value. So here I am setting the new value as 10. So if you go in the HTML, I have added two buttons. One is to set the value and other is to update the value. So within the set value, we will set the new value as 10. So when we click on the set value, you can see that the new value gets updated in the signal. And one important thing is that these signal values can be kind of subscribed, and all the subscribers will be notified when a new value is available. And the value will be updated at the subscriber only lazily, that is when it is actually needed. So since we are binding it here, it will be updated. Now let's take a look at the update value. So we have a method called update. So here we get the previous value and we can modify the value in order to get the new value. So I am taking the old value and incrementing it by 1. When we click on the update value, you can see that the count is getting updated. Now let's see how we can create a signal containing a complex object. So here I have created an interface called task, which has a name and a status. So let's create a signal based on this interface. So this property called tasks. It is a writable signal which has the interface task, and it is a list. So here I have given the initial value with a single object within the array with the name as code and status as false. Previously we saw the set and the update methods. Similarly, there is one more method called mutate. So before going into mutate, let's see what's the difference between update and mutate method. So in the case of an array, you know that arrays and objects are created with reference. So these are basically reference types. So when you create a new array, the reference of the memory will be changed. So in case you make use of the update, a new array will be returned or a new reference will be returned. So let's see this in action. So here in the update list method, what I have done is that I have called the task.update, and making use of the update method, I updated the status and I am returning the list. But this in turn create a new reference. But in certain cases, you need not create a new reference, but you need to modify the existing array itself or object itself. So in that case, you can make use of the mutate method. So this is the syntax, the task.mutate, and it is similar to the update, but here we are directly mutating the existing signal value instead of creating a new reference. So that's the difference between update and mutate. Now in the HTML, I have added two more buttons, the update list and mutate list. So here, when we click the buttons, we don't see any updates. So for seeing this update, let's add an effect to our application. So what is an effect? So effect is something like whenever a value is updated within a signal, we can trigger some side effects which are not related to updating the value, but something like, for example, we want to log the new value. So in those kind of scenarios, we can make use of an effect. So here I am going to add an effect. So this is the syntax. It accepts a callback which needs to be executed when the value gets updated. So how does the effect know what value it needs to track? So what effect basically does is that whichever signals which we call within this effect or which we give in the callback of the effects, it will track it as a dependency. So here I have given the task signal as a dependency. So what happens is that whenever the task emit a new value, it will execute this effect, and here in the effect we are logging the new value to the console. Now let's refresh our application. So here initially itself you can see that when we create the signal, that is when we initialize it here, that initial value is getting displayed as part of the effect. Now when we try to click the update list, you can see that the new value with the status true is listed. The same thing happens when we click on the mutate list or the update list. So one thing to note is that when we click on the set value or update value, the effect does not get triggered. This is because we are tracking only the tasks since it is being used within the effect. So similarly, in case we want to track the count, you can just add the count signal here, and now what happens is that automatically the count also will be tracked. So the initial value 0 is created, and now what happens is that when either of these value changes, that effect will be executed. So when I click on the set value, you can see that both the task as well as the count, they are being logged. Similarly, the update value, update list and the mutate list. So you previously saw that when we update any of these two values, the effect gets executed. But there can be scenarios in which actually I don't want to execute this effect when the count changes, but I still want to log it. So how can I do that? So we have a function called untracked, to which we can pass the signal which we need not track. So it is basically saying that I want to log the value, but the effect should not be executed when this particular signal gets updated. So I don't want to basically track this signal as a dependency. So currently the effect will be executed only when the task signal changes. So let's see this. So initially the value is displayed. Now when I click on the set value or update value, you can see that the effect is not getting executed. But when I click on the update list or mutate list, you can see that the effect is executed and the current value of both the task as well as the count is getting logged. One important thing to note is that the effects and how it keeps track of the dependencies, it is dynamic in nature. So since we are directly giving these signals, that is the task signal directly within the effect, it will be tracked immediately. But suppose we create a new signal called log effects and initially the value is false. Now what we will do is after 10 seconds we will set the log effects as true, and within our effects what we will be doing is when the log effects change or it becomes true, at that time only we will be logging the task. So now what happens is that since the initial value is false, these two signals won't be coming into the tracked dependencies immediately, but it will come only when this execution path is covered. Let's see this in action. Now initially I am refreshing the application. You can see that the logging is currently disabled and this effect got executed because the logging flag is being tracked. Now after 10 seconds, the logging flag became enabled and as a result the effect got executed. So now what happens is let us refresh this, and in between if we click on the update or mutate list, you can see that the effects are not getting executed. But after 10 seconds when the logging is enabled, at that time if we click on the update list or mutate list, you can see that the effects are getting tracked. So that is why the effects dependency tracking is dynamic in nature. So unless the control flows through these statements, the signals which are within that block won't be tracked. In effects, there is an option to provide a cleanup function, especially in case you have some long running task within your effect. Let's add a set interval within our effect. So here I have added a set interval which basically executes this particular logging every 1 second, and the cleanup function which I mentioned earlier, we can obtain it as a parameter here, and to this cleanup function we can pass the callback which needs to be executed in order to handle this long running task. So here we are taking the timer and clearing it, and when it is cleared we will be logging that the effects are cleaned up. So the life cycle of an effect is usually until this particular component is destroyed. So when the component is destroyed, automatically the effect cleanup function will be called and it will be handled. Other than that, in this scenario, whenever the task signal is updated, at that time also the interval will be cleared and a new interval will be created. So let's see this in action. So first I am refreshing the application. You can see that the set interval is logging the value every 1 second. After 10 seconds, the effects got cleaned up and now the second execution started. Now whenever I update the list, you can see that the cleanup ran, then again it started. Now when I click on the mutate list, the same thing happens. And finally here I have added a toggle child button. What it basically does is that it destroys the child component. So I am going to click on the toggle child. You can see that the fx cleanup function got called and there is no more logging that is happening from within the child. Now when we create the component again, the normal logging starts again. One thing to note is that you can call effects only within an initialization context. That is, here we have called the effect within the constructor. So suppose I want to call this effect, like I don't want to initially itself call it, but on a particular button click, that is, I want to click the start logging button. At that time only I want to start the effect. So how can I do that? So let's try that. I will move the effect to within that method, that is the log method. Now let's see what happens. Now I am going to click on the start logging. You can see that an error happens and it is saying that effect can only be used within an injection context such as constructor, factory function, field initializer, or a function run with run injection in context. So in order to make the effect work, what we need to do is that we need to use the injector and pass the injector as a second parameter. So once we do this, we should be able to call the effect within our log method. So here you can see that once I clicked on the start logging, immediately the effect started, and whenever there is an update in the task, the corresponding effect is logged. As we previously saw, the effects will be automatically cleaned up when the component is destroyed or when a new value update happens. So in some cases, we might need to stop the effect based on some user action. So here in this scenario, I have a button called stop log. So I basically want to stop the logging. So what we can do is we can create something called an effect ref. So the effect ref will be returned when we call the effect. So we can assign the return the effect to this particular property, and within the stop log we can call the destroy method within the effect ref. So once this is called, it effectively stops the execution of the effect. Now let's start the logging. Now you can see that the effect is running and the logging is happening. Now when I click on the stop logging, you can see that the effect is cleaned up and no more logging happens when I click on any of the button. All the signals which we saw till now, all of them were writable signals. That is, we could update the value within that signal. But there are certain kinds of signals which are read-only. So one such signal can be created by making use of the computed function. So here I have created a new property called factorial, and I am calling the computed function. As an argument, you can pass the callback where you can do some calculations or modifications on a particular signal. So in this case, I am calculating the factorial based on the current value of the count signal. So here is within the factorial, I am basically making use of the logic to calculate the factorial. So once I do that, I can directly assign this to our HTML to see the value as a signal. One thing to note is that the interface for a signal that is created from computed function is different from the writable signal. So this is the normal signal which is only read-only. Like if you go within the declaration, you can see that there are no methods that like update, set, or mutate. These are available only within the writable signal. And there is an option to convert a writable signal as read-only as well. You can just call the as read-only. For example, here, in case you need to convert the count to a read-only signal, you can just call it as read-only, and now the count will be a read-only signal, and you can protect it from any accidental updates. So here, once we have added the compute, let's see our application. So here you can see that when the initial value is 0, the factorial is shown as 1. Now when I update, you can see that the corresponding value of the factorial is also getting automatically calculated. So that is one advantage of making use of the computer. When the value of the dependent signal changes, automatically the new value will be calculated within the computed function, and it will be set in the new read-only signal. One final thing we will take a look into is we can pass an equality function while creating a signal. So this can be done for both the normal signal function as well as the computed function. So here, as a second parameter, I am passing the equal option, and for checking the equality, I am making use of is equal from Lodash. So what it basically does is whenever a new value is emitted by the signal, immediately it will check whether the value is equal to the previous value. In case it is equal, it won't emit an update. That is, it won't notify the subscribers. So let's see this in action. So here I have added the equality check in the task signal. Let us start the logging. So initially it is false, but currently once I added the is equal, the update list is not at all triggering any effects. So I am not sure whether it's a bug on my side or on the API side. So I am going to change it to a simple set method. So within the set method, I will be directly updating the value, new value. So when I click on the update list, you can see that initially it updated the value as true, but after that, when I click multiple times, it won't trigger the effect. But in case I didn't give the is equal check here, what happens is that initially it is false. When I click on update list, it becomes true. But every time I click on the update list, the same value is emitted, but a new reference is created. So because of that, the effects will get triggered. So in order to prevent that, we can make use of the is-equal. And one thing to note is that in the case of mutate list, that is mutation, this won't work because we are actually mutating the same reference itself. So the equality check won't work since we are updating the same object. So this will work only for the update and the set methods. So hope you are able to learn something new about Angular signals from this video. See you soon. Thank you.